graph in example 3C, there is clearly an oblique asymptote. This is what one looks like. You see this red dotted line and it has a slope to it. Okay, it's not vertical, it's not horizontal. This is an oblique asymptote. Okay, so hopefully now you can kind of see what one looks like. Okay, all right, we're going to go through the same characteristics for this graph. Okay, we're going to start with domain. Okay, domain, this one, probably this is the most complicated of the three graphs. Okay, yes, asymptotes can be helpful, okay, but we can't rely totally on them when you're determining domain and range. Okay, so good old domain, which is I'm trying to figure out what x values this graph covers. I'm going to go the traditional way and just go from left to right and trace the curve. Okay, remember when you look at this leftmost blue piece, the graph's going to continue this way forever. In this direction, we're going to be getting closer and closer to the y-axis, but never crossing or touching it. And then same thing down here, if you jump to this bottom piece, the blue curve is getting closer and closer to the y-axis, but never crossing or touching it. And then in this direction, it's getting closer to the oblique asymptote. Okay. All right. So if we trace the curve from left to right, okay, I'm coming, you know, start with your leftmost point. Okay. So come way out here. You're covering negative x values. Okay, you're tracing the curve, and then you go up forever. Okay, you get stopped by the y-axis. Okay, you get close. This piece gets closer and closer to the y-axis, but never crosses or touches it. And then you pick up on the blue curve again, way down here, where you know you're getting closer and closer again to the y-axis, but never crossing or touching it. Okay, and then after that, you're covering all the positive x values. Okay, so it's kind of like this leftmost blue piece is covering the negative x values, and this rightmost blue piece is covering the positive x values. What's left out is the y-axis itself. The graph, the blue curve, neither piece touches or crosses the y-axis. So that's a bad x value. Okay, the y-axis is actually a vertical asymptote, even though there's no red dotted line there. Okay, so x equals 0 is a bad spot. So I'm going to write that down. X equals 0 is a bad spot. Okay, and you can kind of see that here. No matter where you are, I'll go ahead and put in a red dotted line. Okay, x equals 0 has no output. Okay, but any other x value you pick, okay, you can draw down to its output. Okay, so the domain here is going to be all real numbers except for 0. All right, so now let's try to figure out range. Okay, definitely a little more complicated here. Okay, all right, range. We need to figure out what y values this graph covers. Okay, we are going to go, you know, from the bottom to the top. Okay, so we're going to start, here's the bottommost point on the graph. Okay, we go down, down, down forever. So the lowest y value is going to be negative infinity. And then if we're traveling on this piece, here's the high point. Okay, the high point is right here. Okay, this is the point 1, -2. You need to write down the y value because this is range. Okay, so the highest y value is -2. That's a closed circle, so we want to include -2 in the range. Okay, so that's the range for this bottom piece. Okay, and then we take a break. Okay, we don't, you know, if you're traveling up, you're going from the bottom to the top. The next point you hit is right here. Okay, on this leftmost piece over here, this is the lowest point. Okay, so this point has coordinates -1, +2. Okay, so the next y value you hit is going to be +2. You want to include it because there's a closed circle there. And then all the positive y values are covered after that. So you're going to go off to infinity. Okay, so this is the range. Okay, it's basically all real numbers except for the y values between -2 and +2. Okay, and another way you can see the range, let me erase this stuff. Okay, if you kind of look where I'm highlighting blue, if I look in this area, there's no blue curve between y equals -2 and y equals +2. Okay, the two blue pieces exist outside of this blue zone. Okay, this blue zone covers y values between -2 and +2. Okay, so those are the y values that are not in the range. All right, we got domain and range. Let's talk x-intercepts now. Okay, so I am going to pick another color. Okay, let's trace the x-axis. Okay, the blue curve, neither piece ever hits the x-axis. Okay, and in fact, let me erase all this stuff because it's starting to get really busy here. Okay, if we trace the x-axis, okay, neither blue curve intersects the x-axis. Okay, so there's no x-intercept. Similarly, if we trace the y-axis, the blue pieces never touch or cross it, so there's no y-intercept. Okay, so no x-intercepts, no y-intercepts. Okay, now we're just going to write down asymptotes. Okay, so let's start with horizontal. Okay, a horizontal asymptote, okay, that needs to be a horizontal line that your blue pieces are getting closer and closer to, but never touch. Okay, your immediate thought might be, hey, the x-axis is a horizontal asymptote. It's not. The blue pieces are nowhere near the x-axis. It needs to be a horizontal line that your graph is getting closer and closer to. Okay, not happening here. Okay, we have, here's the thing. Okay, a graph can have a horizontal asymptote or it can have an oblique. It cannot have both. This graph clearly has an oblique asymptote, so as a result, there will be no horizontal asymptote. Okay, so remember that a graph can have one or the other, but not both. Okay, vertical doesn't apply to that. Okay, a rational function, its graph can either have a horizontal asymptote or an oblique, can't have both. Okay, no horizontal asymptotes here. Okay, vertical, there is a vertical asymptote. Okay, don't rely on always being given your red dotted line. Chances are you won't have that. Okay, but the y-axis is definitely a vertical line that the blue pieces, actually both of them, are getting closer and closer to without touching or crossing. Okay, so the y-axis, which has the equation x equals 0, okay, any point on the y-axis has an x value of 0. Okay, the one lone vertical asymptote here is going to be the line x equals 0, which is the y-axis. Okay, there is clearly an oblique asymptote here. It's the slant asymptote. Okay, and you're like, well, how do I write down its equation? Okay, well, it has the format y equals mx plus b. Okay, so we just need to figure out the m and the b. Okay, the y-intercept here is 0, 0. Okay, and I'm not saying of the curve, I'm saying of the asymptote. Okay, you're trying to come up with the equation of the red dotted line. It crosses the y-axis at the origin. Okay, so the b value is going to be 0. Okay, the m, we need to figure out the slope. Okay, so here's a point on the curve, -1, 1. Okay, the origin is also on the red dotted line, so we need to go down 1, right 1. Okay, down 1, right 1. Okay, so the rise over run is 1 over 1, and this is a negatively sloped curve. Okay, so the slope is -1. Okay, so the equation of the oblique asymptote is going to be y equals -1 times x plus 0. Okay, so the equation is y equals -x. There's your oblique asymptote. Okay, and these are the characteristics of this particular graph.